In early April of 2026, a rare triplet of tropical storms formed simultaneously over the western Pacific Ocean. The counterclockwise spin of the northern storm colliding with the clockwise spin of the southern systems forced high speed gusts to blow directly backward against the ocean's typical trade winds. This intense atmospheric friction stalled the normal flow of water moving west. Stuck in place, a massive pool of warm water began piling up just beneath the surface. A few days of anomalous wind across a single stretch of water set the mechanical foundation for a cascading planetary scale disruption. Forecasters analyzing this surface anomaly predict these stalled winds will push the ocean into a moderate to strong El Nino as early as mid June. This chart of European Center predictive models shows ocean temperatures projected to spike by a massive 2.5 degrees Celsius by October. Crossing that specific 2.5 degree marker pushes the classification from a standard weather event into a highly destructive Super El Niño. The data indicates the world is bracing for one of the most extreme climate events recorded in the last 140 years. Normally, the Pacific Ocean operates like a massive conveyor belt. Trade winds blow consistently, pushing surface water away from South America and across the ocean toward Asia. As that surface water vacates the eastern edge, a mechanical void is left behind. Deep, frigid water gets pulled up to the surface along the South American coast to replace it, a process known as upwelling. This cold water drags deep sea nutrients up, creating massive plankton blooms that support immense global fisheries. Meanwhile, the water that was pushed west spends weeks absorbing sunlight. By the time it reaches Indonesia, it evaporates rapidly, driving heavy rainfall across Southeast Asia, a cold eastern ocean and a hot western ocean. Maintaining that stark thermal divide is the engine that keeps global weather patterns predictable. When those trade winds lose momentum, the conveyor belt halts, upwelling shuts down, and the entire Pacific begins to retain heat. This excess surface heat further degrades the Pacific trade winds, causing a violent, suffocating reversal of ocean currents. To track this feedback loop, organizations like NOAA rely on floating buoys inside a very specific equatorial zone known as the NEM plus O 3.4 region. The metric is remarkably sensitive. If average temperatures in that zone rise by just half a degree Celsius, an El Nino is declared. A half degree drop signals its cooling counterpart La Nina. A fractional temperature shift in the middle of the ocean dictates the stability of ecosystems worldwide. That massive buildup of Pacific heat acts as thermal fuel, spawning highly destructive hurricanes that repeatedly batter Asian and Pacific island nations. The displaced atmospheric moisture guarantees severe flooding across the Americas while simultaneously draining the sky over India, Central America, and Australia, leaving fractured soil and failing crops in its wake. During the 1997 Super El Niño, these erratic rainfall patterns devastated local infrastructure, causing thousands of fatalities and billions in damages globally as entire coastal communities vanished underwater. Beneath the surface, the sudden loss of cold, nutrient rich upwelling starves out marine food webs. Species unable to migrate fast enough, like sockeye salmon, suffer mass die offs in the suffocating heat. For delicate environments like coral reefs and kelp forest, the thermal shock causes multi year devastation that can take decades to recover from. This thermal shift dismantles food security, destabilizes national economies, and redraws the physical geography of multiple continents simultaneously. This disruption arrives on a planet already struggling with record baseline temperatures, magnifying the impact of every flood and heat wave. Relying on advanced predictive modeling from agencies like NOAA gives farmers, fishers, and governments the critical lead time required to prepare their infrastructure for the shock. While a 2026 Super El Nino is not an absolute certainty, the narrowing window to prepare serves as a strict test of our endurance against an increasingly volatile planet.